Here we go for chapter 6, excuse me, writing and solving systems of equations. So what we've got is a situation where we've got three linear equations. Now that we've done 3D vectors, hopefully you can see what we've actually got is the Cartesian form of a 3D vector. And we want to work out where all three of these have a solution. So the first strategy we're going to look at is writing this as an augmented matrix. So the beauty of this is that we actually don't have to keep writing the x, y's and z's. The columns represent this for us. So these are our x values, these are our y values, these are our z values, and often you'll see we throw in a dotted line to differentiate between the variables, and this is our equals, so the constants. Okay. What we can do with this is we can change the rows if we need to. So if we don't like the position of a row, we can move them around. We can multiply any row, so we can multiply it by 4 or 2 or a quarter or a third, or whatever we think will be helpful. And we can add rows together and multiples of rows together. One strategy that we're going to look at is manipulating these rows until we have what's called an echelon form, and that's where we have ones down the leading diagonal. We've got a row where we've got 2 zeros and a 1, 1 0 and a 1, and then all of our values. And by doing that, what we can see straight away is our z value, and then once we know our z value, we can substitute it in to find our y value. And then we can substitute x and y in, z and x in, to find our x value, okay? We can continue reducing the matrix until we have what we had before. However, we can go even further and have it so we have a leading diagonal of ones, everything else is 0, so we can see very clearly that z is whatever that constant is, y is whatever that constant is, and x is whatever that constant is. So this is the extreme version, but it is handy as well if you want to be sure that that's what you've got. So I'm going to show you an example of this extreme version, show you how much work it is, and then give you some shorter strategies as well. So with our question, so this is what we are trying to solve, okay? And our goal this time, I'm going to show you the extreme version, the reduced echelon matrix, where all we end up with is a leading diagonal of ones, and then the rest are zeros, so we can look straight at our matrix and see our solutions. So let's start with, I'm going to start with subtracting row 2 with row 3, and we can see by doing that, I'm going to get a 0 here. So that's why I chose that combination. So I've gone 2 take 2, 1 take -3, 3 take -1, and 4 take -4. Then I'm going to divide the whole of row 2 by 4 because we can see all of these are multiples, and so that gives me a nice row with 1s and just a 2 as a constant at the end. Then I'm going to do row 1 take row 3 because that will mean this 3 will be reduced to a 1. Okay, so you can see I'm starting to get my 1s where I want them to be, and I've already got a 0 there. Remember, this is our goal. This is what we're trying to do for our extreme version. Next, I'm going to do row 3, and I'm going to take 2 lots of row 1. And by doing that, I've got 3. I'm going to take 2 of those, so I'm going to get myself that 0 there. Okay, so there's more of my zeros. Now I've got a nice row 3 here, where those are all multiples of each other. So again, I'm going to divide row 3 by -5, so I get my get 1s rather than 5s and 20s. Now my next step, so what do I need? I need to get another 0 here. I need to get, this is a positive, I need to get this as 0, and so I need to keep going through. So the next step, I'm going to do R3 take R2, so that's going to get rid of that one there. Okay, now I can see again, I've ended up with, and now I've ended up with multiples here, so I'm going to change them back into 1s. All right, So I'm getting pretty close here. So I've got all my zeros down here. Now, if I wasn't going to the extreme version today, if I was actually going to stop here, this is enough to solve, because hopefully you can see I've actually solved for z here. And then once I solve for z, I could solve for y and I could solve for x. I'm going to do an example of that next, but I am going to keep going because I want to show you the extreme version today. All right, so next I still need a 0 here, here, and here. So I'm going to do R1 take R2, because that's going to get me my 0 here. Next, I'm going to do R1 and then 4 row 3s, because then if I add 4 row 3s, I'm going to get rid of that -4. Beautiful. And look, all I've got now is that 1 there that I'm trying to get rid of. I can see if I subtract this row, because these are all zeros, obviously, they're not going to impact the first two positions. I can take 1 from there. And there we go. I've ended up with a beautiful reduced form echelon matrix. And so what I can see from here is that Z is -1, Y is 3, and X is 2. Now I'm sure you can see like that's a lot of work, but that is one way to do it. I've got a quick summary of what we did. So what we want to do is try and make sure we get zeros in the rows below, and we want to make sure we've got the first non-zero entry, okay? And another strategy that we didn't use, but sometimes when you've got horrible numbers that you can't see, you might have to try using the reciprocal, all right, to do that. All right, my next example, I'm going to show you one where we don't go to the extreme, because you probably were looking at that going, what, I have to do that much work every single time? No, you don't. What we can do is we can get ourselves to just a form where we can solve for 1 variable, then 2 variables, then 3 variables. So I'll show you what I mean. So we've got a professional DJ wants to purchase some records. We've got 40 rock albums, 32 pop albums, 14 dance, and there are some packages. So in the A package, you can buy 2 rock, 4 pop, and 1 dance. That's the B package, that's the C package, right? So we need to find some kind of combination. So put these in, so we know that the rock has to total 40, the pop has to equal 32, and the dance has to equal 14. Okay, so make sure you agree with where I've got those values from. All right, let's start. So we're going to do R2, take 2 lots of R1. And lo and behold, because we actually started with a matrix with a couple of zeros, this is all I actually have to do, because hopefully you can see here, I now have a row with 2 zeros and just 1 value to solve for. Okay, so that's this row here. I then have another row, or both the other rows just happen because we had zeros to start with. Both of the other rows happen to have 1 0, and then the last row doesn't matter, we've got an extra 0. So what I can actually do from here is I can go, well, our B value is -6, and we know -6b equals -48, so b equals 8. I can now take that b equals 8, put it in here, and say, well, 2a plus 4b's, which we know is 8 now, equals 40. That's going to become 32, so a must equal 4. And now I know a equals 4. I can go 4 plus 2c equals 14, and c equals 5. So the DJ needs 4 pack A's, needs 8 pack B's, and 5 pack C's. Okay, so obviously you can see that's a lot less working. They won't all be just one step, but just noticing that once you get to that form where you've got 2 zeros, 1 0, and that one happens to be 1 0 as well, then that's all we need to be able to solve. All right, 2 more examples, guys, and then you'll be ready to start 6A. So a bit of a worded question now, so making sure you can take a worded question, write your equations, put it into your matrix, and then solve. So we've got a situation where the Olympic Games Advertising Committee spent a total of $6,000 on TV, radio, and magazine. back before the internet was probably the main form of advertising. So the statements that we've been given is as much was spent on TV advertising as radio and magazine together, and the amount spent on magazines and TV combined was equal to 3 times that on radio. So we've got T represents television, R represents radio, and M represents magazines. So we know that all 3 of those together equaled $600,000. We also know that television is the same as the radio and the magazine combined. And we also know that the magazines plus the television was equal to 3 times the radio. Now be really careful. So once we've written our equation, so we've got 3 equations, so that's all we need to solve for 3 variables. But we've got to make sure our order is correct. So let's just start with the order that they gave us the variables, T, R, and M. So we've got T, R, and M. So let's model the rest of our equations on this first one and go, all right, I need to have T first, then R, then M. So all I've done is rearrange. Same with the second, T first, then R, then M. Because we don't have the order the same, then obviously the columns in our matrix aren't the same variables, and so it's not going to make any sense. So now that we've got our T's, our R's, our M's, put that into our matrix, and off we go again. So I'm going to start with row 3, take R2, then row 2, take row 1, finally row 3, take row 2. Okay, and there I've got it. I've got 2 zeros, 1 0, and I don't need a 0 in the last one. So from here I can see that my M value, so 4 M's is 6,000, so M is 150,000. Then I can substitute that M value in here, so I go negative 2R, take 2 lots of M, is negative 600,000. Solve, and we get R is 150,000 as well. That's our R. And so now we've got M and R plus T, equals 600,000, and so T equals 300,000. Okay, so that's the amount he spent on each of the advertising campaigns in dollars altogether. Right, lucky last. So solve the following systems of equations. Again, I've been really generous and made sure I've written them in the correct order, but always check when you're given the equation that they do have the first variable, the second variable, the third variable, and the constants all lined up. If they're not, you have to rearrange them first before you put them in the matrix. Alright, so put them in. So think about where you want your zeros. So I want my first 0 here. So I want R3, take R2 to give me my very first 0. Next I want a 0, next I want a 0 up here. So I'm going to go R1, take 2 R2s. Then I want to just get rid of those negative 3's, so then it makes it easier to do further calculations. Okay. And remembering as well, sorry guys, went too fast. Remembering as well, you can do more than one calculation at a time. So I've been trying to go quite slowly with one operation at a time. But when you can see, especially when you're close to the end, if you can see what you need, you can actually do 2 calculations in one go. So in this, to jump from this matrix to this matrix, I jumped straight to R1 divided by negative 3's, just so I had 1's there, so it was nicer to see. And I also went, well, I know R2 take R1 is going to give me my zeros where I want them to be, and then I can solve. Now I think I've made a mistake, have I? So I divided that by 3, and then I went R2. Oh, that's supposed to be R3. Sorry guys, typo in my calculations. Just change that so I don't have to start all over again. Just change that to a 3. I actually did R2 take R3. That's better, isn't it? Because then R2 take 3 would give us negative 1, 0. Now that's better. Okay, sorry about that. And now from here, we can see we've got our y value. So our y value straight up is just 1, so that's nice and easy. Now we can use our y value, we can substitute that in here. So then we've got x take 1, because we've got negative 1y equals 0. So x equals 1 as well. And then we can put 2 lots of x, which is just 2, plus z equals 1. And z is going to equal negative 1. And obviously you can always take the time if you are not sure if you got there in the end. You can always take the time to go back and just check when we substitute all those values into the original equation, we get the same, and that way you can be 100% confident. All right, thanks Year 12. So that's our examples. The book obviously has an excellent introduction as well, so if you feel like this wasn't enough for you, please read the introduction to the 6A chapter. They've got heaps of other examples and hints and what to do if you get stuck. But otherwise, 6A, have a go at those. All questions. Thank you.